All right, guys, let's get started with the mini lesson 8.3. We're going to simplify radical expressions. So the learning objectives we're going to look at today are three. Use the product rule for radicals, use the quotient rule for radicals, and we're going to simplify radicals. We're going to do the distance and midpoint formulas later. But just some notes up here in the corner where you see the orange marking. Remember, A is an element of the reals, B is an element of the reals, which means that either one of those numbers can be any number. So the product rule says that if I have any nth root and another nth root, and the two numbers are different, I can multiply them together. So the nth root of A and the nth root of B is the nth root of the product of A and B. Similarly, the quotient rule is if you take the nth root of some fraction, A over B, you can literally do the nth root of the numerator and the nth root of the denominator. Just make sure that the nth root of the denominator does not equal 0, and we should know why. We'll go look through a few of these problems. The notes will be provided for you, so you shouldn't have to worry about that too much. Number one, use the product rule to multiply. Assume that all variables represent positive real numbers. So we really don't have to worry about absolute values or anything like that. We're just worrying about positives here. So you can see in 1b, I took the cubed root of 7 times the cubed root of 9. And then what did I do? Since they have the same index number, 3, I simply multiplied the radicands. 7 times 9 is 63, the cubed root of 63. You can't break it down any more than that because the primes would be 7, 3, and 3. And hopefully you're noticing the little comments. So 1c is the square root of 5x times the square root of 3y. I just multiply the insides, if you will, and then I come up with 15xy. If you go use the quotient rule, we have two problems here to work out. So it says, use the quotient rule to simplify. And again, assume all variables represent positive real numbers. So we're still working in the same category. So I just broke down the cubed root of 2 over 8x to the 9th into the cubed root of both top and bottom. I then separated by the product rule because I have an index, right, of 3. So I separated them because I know the cubed root of 8 is what? 2, because 2 times 2 times 2 is 8. And that's where the 2 came in. Then I rewrote the cubed root of x to the 9th as a rational exponent, just to remind you of just kind of going back and forth, and also it's a little easier to see that 9 divided by 3 is 3. So we have the cubed root of 2 over 2x cubed. Okay? A lot of times it's a little bit of a game, and you got to play around with it. So e, negative cubed root of 125x over y to the 9th. So again, I used the quotient rule, and I broke the numerator and denominator into their pieces. So in the first part, I simply did what? I took the cubed root of 125x, and I took the cubed root of y to the 9th, numerator and denominator. Then I decided to separate them out because I know the cubed root of 125 is 5, and you can see the justification over here that when I multiply 3 5s together, I do get 125. The x, on the other hand, has no other parts to it, so it just stays the cubed root of x. And again, I rewrote y, the cubed root of y to the 9th to y to the 9 over 3. And when we crunch everything together, we come up with negative 5, right? Because I can only take one of these out because the index number is 3. So it would be negative 5 cubed root of x all divided by y cubed. Okay, number 3. Simplify. assume that all the variables represent positive real numbers. Now, there's different ways to attack different beasts, and everybody has a different way of doing things, so it's not a big deal. So there's a couple of different basic ways to look at it. You could factor it, basically, or you could look for perfect squares. In the very first, or the top part, you can see I'm looking at the perfect squares. I could have gone directly to 16 times 3 to get to 48. But just in case, if you're used to 4 times 12, I broke it into primes here so you could see it. The square root of 16 is 4, and the square root of 3 is the square root of 3. The alternative version is down here, and I just broke it all up in from the primes, and the square root of 4 is 2, the square root of 4 is 2, and the square root of 3 is square root of 3, which is exactly what we have here. So 2 times 2 is 4, and these two things are the same darn thing. All right. Now, let's move on to L. So we're still in simplifying. And you can see what I did. Because the index numbers are 2, it's just not listed. Remember, there's really a 2 and a 2 here. I combined them, and then I simplified. I did what? Cancel, right? Then I broke them up into pieces. So the square root of x to the 6th is x cubed, and the square root of y squared is y. But remember, it's really the absolute value of y, but we're just talking about the positives. If you look at the alternate version, I use it all with rational exponents. Not much has changed. And again, the two are exactly the same darn thing. Boop. Okay. So hopefully you're okay following this information. You'll have to let me know in the stream. Oh. No. Okay. Well, the fifth root of 729 x to the 9th y cubed divided by the fifth root of 3x squared y to the negative 7th. So we know right off the bat, after we change the whole fraction into a root of 5, or the fifth root, as I did here, the y to the negative 7, because it's an inverse, right? It's negative, so that means if it's in the bottom, it shoots up to the top, and that's where I got the y to the 10th. After simplifying, I did 729 divided by 3. I did x to the 9th divided by x squared. That gave me x to the 7th. And then I combined the y's to give me y to the 10th. Taking the fifth root of 243 gives me 3. Taking the fifth root of x to the 7th, I broke that down down here. And hopefully you see the logic, but give me a second. And then times the fifth root of y to the 10th. So I rewrote y to the 10th right away, and x to the 7/5 right away. I changed them right into rational exponents. And the reason why is basically, if I can just zoom in here for just 1 second to give you a better view, you can see what I'm breaking 7/5 down into, right? 5/5, which we know is what? 1. And the leftover 2/5, which would then make the 7/5. So now when we put this all together, we now know that we have 3x for sure, and a what? Y squared. The only thing that doesn't cancel out is the x to the 2/5 power. So I just rewrote that right here. So my advice is to use the rational exponents. I think that they're great. Okay, hopefully that's all right. We're going to set up for the next one. And hopefully you can also work on your own. There's plenty of problems and examples here. As like I said, the notes are presented and the solutions are presented, so you can take a look and work them out. I hope this helps, and make sure you have a great time reviewing this material. See you soon.